Previously, we talked about Karl Popper and how the popular belief out there that science never proves anything is his brainchild. With that, he also coined the term pseudoscientist and moved the philosophical goalposts as to what science actually is and redefined it entirely. Rather than defining science as knowledge concerning a given subject, he chose instead to define it as a state of ignorance concerning a given subject. To know something is to have proof of something, and according to him, a belief that something has been proven is the thing that makes someone a pseudoscientist. So if you believe it can be proven that some cats eat food, then you're a pseudoscientist.
Eine wissenschaftliche Theorie ist vielleicht wahr im Sinne des absoluten Wahrheitsbegriffes, aber wir können es nicht beweisen. Wir wissen nicht, ob sie wahr ist. Alles, was wir sagen können, ist, dass sie sich bewährt. Aber wir haben die Wahrheit sozusagen nicht in der Tasche. Und sogar wenn wir sie in der Tasche haben, kennen wir sie nicht als wahr. Können wir sie nicht als wahr identifizieren.
I think the no true Scotsman example describes this quite nicely. Let's take a look at the example here. Angus declares that Scotsmen do not put sugar on their porridge. To which Lachlan points out that he is a Scotsman and puts sugar on his porridge. Furious, like a true Scot, Angus yells out that no true Scotsman puts sugar on his porridge. This kind of monologue can more or less be seen between the philosophies of Karl Popper and Thomas Kuhn. Popper says true scientists are never certain about anything. But Kuhn over there says that isn't the case. There are lots of things that many scientists feel very certain about.
According to Popper's falsificationism, scientists are always busy trying to prove their own theories wrong. They are very critical indeed. Pseudoscientists, on the other hand, are always trying to protect their theories. They are not critical at all.
So according to Popper, all of those globalists out there who don't dare question the globe Earth model, they are all a bunch of pseudoscientists. And because of Popper's high regard for being super skeptical about everything, a lot of flat earthers really like him. Though if you really want to buy into Popper's philosophy, you can't make any definitive claims whatsoever, which is where his whole philosophy falls apart.
So for Popper, being critical is like a definition of being a scientist. And many people agreed with his idea. But not everyone.
Thankfully.
Thomas Kuhn, an American physicist, historian and philosopher of science, developed an extremely influential account of science according to which the idea that science is critical is mostly an illusion. Or to be more precise, it is an illusion most of the time. Most of the time, Kuhn argues, science isn't very critical at all.
This is exactly what we see in our typical science textbooks. Page after page of them preaching things that they claim to be facts. They don't say that the Earth might be a globe. They claim the Earth is a globe, which is a problem, but bear with me here.
It's only at specific and exceptional moments in history that science becomes critical. So if we believe that science is always critical, we are mistaking the exception for the rule.
So Kuhn acknowledged that the state of uncertainty is just a phase that people go through. But in time, that state of uncertainty disappears. When I first heard about the flat Earth, I was really skeptical about it. But over time, my uncertainty dissipated, and I became quite certain that the Earth is flat. And Kuhn steps up and says that my certainty doesn't make me a pseudoscientist. In fact, it makes me a normal scientist.
Kuhn's key insight is that although scientists are usually critical about new ideas and cutting-edge theories, there is also a lot that scientists are not critical about. Every scientific discipline, Kuhn says, has a huge number of theories, ideas, concepts, methods, measuring instruments and so on that all the scientists in that field simply take for granted. They are never critical about them, and they generally don't even discuss them.
Some cats eat food can be acknowledged as a scientific fact that we don't need to be critical about.
Kuhn's theory is based on his own work as a historian of science. When Kuhn studied the history of science, he didn't see a chaotic succession of events. Instead, what he saw was a kind of pattern of alternating phases, of different kinds of science that happened at different moments and which followed each other in a standard way.
It makes a lot more sense.
According to Kuhn, you could see this pattern everywhere, in all the sciences, or at least all the natural sciences, and throughout history. So, what are the phases that Kuhn identified? There is first the pre-paradigmatic phase.
This is Popper's state of uncertainty.
Second, there is the phase that Kuhn calls normal science.
This is where we stop being critical about something, accept it as a true concept, and build on that. Some globalists out there might see boats appearing to sink on the horizon. Then they say, hey, that proves that the Earth is a globe. And then after that, they stop being critical about the shape of the Earth and build their worldview on that.
Third, there is the phase of crisis.
This is where a globe earther sees something that doesn't quite add up with their model, like being able to see too far, and that causes them to become skeptical again.
And fourth, there is the phase of scientific revolution.
This is a state where one concept replaces the old one. In this case, a person acknowledges that the Earth is not a globe, abandons that model, and takes on the Flat Earth model. Welcome to Flat Earth. This is all significantly different from Popper's philosophy. Popper states that science is a state of ignorance, while Kuhn states science is a process of attaining knowledge, even if that knowledge is sometimes wrong.
Every science, Kuhn tells us, starts in a pre-paradigmatic phase. At some point it will move on to the phase of normal science. Once that has happened, that scientific discipline will never return to the first phase. So pre-paradigmatic science happens only once for any scientific discipline. The other three phases, however, will occur many times. From a phase of normal science, we can move to a phase of crisis. From a phase of crisis, we will return either to normal science or go on to a scientific revolution. And from the phase of scientific revolution, we will always go back to normal science. Normal science really is the usual state of things. It's the phase that we are in most of the time and that we always return to. So to understand Kuhn's theory, we first need to understand what normal science is. All these things, theories, concepts, methods, whatever, that a scientific discipline takes for granted, is what Kuhn calls a paradigm. Paradigm, that's a very important concept. Normal science is by definition that phase of a scientific discipline when there is a well-functioning paradigm. That is, a paradigm that the scientists in that discipline are confident about.
So the belief that the Earth is a globe and the belief that the Earth is flat can both be described as different paradigms.
During normal science, which is basically science as we all know and learn it, scientists trust this paradigm, and the main scientific activity can be seen as solving scientific puzzles within the rules of the paradigm. Now, Kuhn goes on to make two important points about paradigms during normal science. First, he points out that they consist of things that scientists don't just take for granted, but that they don't even want to be critical about. Scientists believe that it would just be a waste of time to be critical about the paradigm. Imagine the reaction of a historian if you told her that maybe Julius Caesar didn't really die in 44 BC, but that he survived the attempted assassination and then went on a long and secret journey to China. Or if you told her that maybe our Latin dictionaries are completely wrong and that every Roman text we have means something utterly different from what we think it means. She would not be very interested in pursuing those ideas. She would just roll her eyes and get on with serious work. You could never write your BA thesis about such a hypothesis. So we see that during a phase of normal science, people are not interested in being critical about the paradigm.
This is why it is so hard to get the flat Earth through to mainstream academics. They become so engrossed and indoctrinated by their paradigm that they don't care to think about anything else.
Second, Kuhn points out that this is a good thing. It is only because we take so much for granted that we can get any detailed work done in science. If a historian couldn't trust the archaeologists and the dictionaries, and if she had to question all the basic facts of her discipline all the time, then she would never be able to make much progress. We can only answer detailed questions about history or about any other subject because we can take a large theoretical and methodological background for granted. It is only that because there is so much we don't have to think about that we can really focus our thoughts on the single question before us.
But obviously this can be very problematic when scientists sit on enormous errors that they don't bother to check.
So let us return to the question of whether scientists are critical. According to Kuhn, they're not all that critical, because they don't criticize their paradigm. There's a lot of stuff that scientists just take for granted. Just like there's a lot that you as students are simply taught as the facts and not supposed to be critical about.
It is okay to acknowledge that some cats eat food is a scientific fact. Acknowledging that fact, we are then able to go forward and develop an entire field of science dedicated to cat nutrition and studying what kinds of foods are healthy for cats to eat as compared to not healthy. Despite what Popper claimed, acknowledging a cat's diet doesn't make you a pseudoscientist.
And Kuhn goes on to say that this is good, because if we were being critical all the time, we could never get any work done and there would be no scientific progress. But if that's true, why do we nevertheless believe that science is critical? According to Kuhn, that has to do with the other three phases of science. So what about the other phases? Let's start with the first phase, the pre-paradigmatic phase. As the name indicates, this is the phase before there is a paradigm. Every scientific discipline starts out without any shared concepts, theories and methods. Those still have to be thought up and developed by the scientists. The first historians didn't agree about the right way to write history. The first physicists didn't know what the right concepts were to talk about nature. The first linguists didn't have any generally accepted linguistic theories, and so on. Since there is no set of shared concepts, theories and methods, individual scientists in the pre-paradigmatic phase will generally do very different things. They have different background assumptions, do different kinds of measurement, have very different ideas about which problems are worth investigating, and so on. It's also very hard of them to communicate, because they don't have a shared technical vocabulary. They never really know whether they're all talking about the same thing. In such circumstances, it is almost impossible for scientists to work together. Rather, everyone is pursuing their own ideas, and when scientists do interact, it is mostly to argue that their own concepts, theories and methods are superior to those of other people, and that other people's results are therefore worthless.
This sounds to me a lot like some of the infighting we see amongst different flat earth channels. Their flat earth model is different than my flat earth model. Therefore, that person must be a shill or controlled opposition.
So pre-paradigmatic science doesn't really look like science as we know it, as unified, or at least somewhat unified disciplines with clear standards and a shared body of assumptions.
So the pre-paradigmatic phase is Popper's ideal world of total chaos.
According to Kuhn, this phase of science isn't very productive. Because scientists can't work together, they can't build on each other's results, which means that everyone is constantly starting from scratch. So it is very good for a scientific discipline, Kuhn thinks, when for one reason or another, maybe because of some great results or because of dirty politics or whatever, one set of theories and methods becomes dominant. Once that happens, once scientists in a pre-paradigmatic discipline fall in line behind a single set of ideas, that's when we have a paradigm. And then we move from pre-paradigmatic science to normal science. Scientists start working within a paradigm that they are no longer critical about, and that means they can finally work together to solve detailed problems. But paradigms don't last forever, which means that a discipline doesn't always remain in a state of normal science. Here Kuhn introduces the concept of an anomaly, a problem within the paradigm that scientists are at present unable to solve. An observation that doesn't fit with the basic theories of the paradigm, for instance, would be an anomaly. Now Popper would think of an anomaly as a falsification. It shows that the theories are wrong. And for Popper that means we have to reject the theories and thus reject the paradigm. But Kuhn thinks about anomalies in a very different way. He claims that every scientific discipline always has anomalies. There are always things that scientists at present don't know how to explain.
None of us are omniscient. We don't know everything.
But that doesn't worry them. They assume that they'll solve them in the future. The existence of anomalies is not a problem for a scientific paradigm, says Kuhn, as long as scientists remain confident that they will be resolved in due time.
It's a fair question. Let's do this. Let's put a pin in it. Boop, pin in. There you go. Now, let's let that hang there a bit, and then we'll address that when we thought things through, okay? Good enough for everybody? Smiles all around? Let's get out of here.
So globe earthers, when they see something that doesn't jive with their model, they can say, I don't know the answer to that, but I'm sure there's a globe earth explanation somewhere that I just can't find right now. And flat earthers can say the same. This kind of behavior is really easy to villainize, especially in a debate. But it's okay. That which you don't know doesn't outrule that which you do know.
But it is possible for scientists to lose that confidence. If the number of anomalies keeps growing, and if scientists have almost no success when they try to solve the existing anomalies, then, Kuhn says, scientists will start to doubt whether they can ever solve these anomalies within the current paradigm.
As your knowledge grows concerning other topics and you put more puzzle pieces together, eventually it becomes more and more obvious that that concept just doesn't fit.
When that happens, we have reached the phase of crisis. So a crisis is a phase when scientists start doubting their own paradigm. In normal science, scientists have confidence that the paradigm will allow them to solve all the puzzles they want to solve. In a time of crisis, scientists are losing that confidence.
A globe earther becomes a globe earth skeptic.
This means that in times of crisis, scientists become critical of the paradigm. They start wondering whether it shouldn't be changed. They become interested in radical new ideas, new theories, new methods, new concepts. They start to think out of the box, so to say, outside the paradigm that they have been using for all these years. And the longer a crisis lasts, the more critical scientists become and the more radical are the new ideas that they take seriously. Now, there are two ways to end a crisis. One possibility is that some of the most important anomalies are solved within the current paradigm. Then the confidence of scientists in their paradigm will be restored and we go back to normal science. The crisis is over. The second possibility is the more dramatic. It is that a new paradigm emerges, a new set of theories, concepts and methods that promises to solve some of the most important anomalies. If the majority of the scientific community embraces this new paradigm and abandons the old paradigm, then we have reached the fourth phase of science, a scientific revolution.
Concerning changing the mainstream view of things, that kind of thing doesn't happen overnight, but it is a gradual victory that is won one person at a time. And this is happening with the flat earth. School teachers are waking up. When I spoke out in Draper, Utah in our December Flat Earth meet and greet, that was at a school, and it was amazing. I tell you, this stuff is happening, and it is a privilege to be a part of it.
Kuhn also calls this a paradigm shift. Such revolutions are the most dramatic episodes in the history of science. One way of thinking is abandoned, and an entirely different way of thinking is accepted. These are moments which define scientific disciplines for decades or even for centuries. When we look back at the history of science, Kuhn points out, these scientific revolutions are the most noticeable moments. Because of that, people often think that science consists of revolutions and that it is a very critical activity. But in fact, Kuhn says, revolutions are the exception, not the rule. The rule is normal science. The vast majority of scientists do the vast majority of their work within a stable paradigm. They are solving puzzles without being too critical about the paradigm that they are working in. When normal science gets stuck, that's when a revolution can shake things up again. But most of the real work, most of the detailed solving of problems is done by normal scientists during normal science. Kuhn's picture of science then is quite different from the view of science that many people have. It has been immensely influential. The idea of a paradigm is very useful for understanding science, as is the interplay between normal science and revolutions that Kuhn identifies. Things become a bit more controversial when Kuhn starts talking about scientific progress and what he calls incommensurability. But we'll get there in a moment. Let us start by painting a traditional picture of scientific progress.
So here this illustration represents the world's accumulated knowledge over time. Every time we learn something new, we just add it onto that building.
So that building is basically growing and growing and growing, and that's what progress consists in. Now, even the traditional picture isn't quite that simple. Sometimes scientists make mistakes, and it takes time to recognize the mistakes. So once in a while, a part of the building of science has to be demolished, and something else has to be built to fill up the hole.
When the globe Earth gets demolished, the flat Earth comes along to fill in the hole.
But on the traditional picture of scientific progress, these holes are relatively small. They don't cause the collapse of big parts of the building.
That might usually be the case, but flat Earth is obviously not one of those cases.
Overall, the accumulation of knowledge is a smooth process. Kuhn, however, points out that once you accept his theories of paradigms, a very different picture emerges. We must remember that paradigms set the standard for what is good and what is bad science. Scientists who use the theories of the paradigm, who employ its concepts and methods, and who share its worldview, will be judged to be doing good science. Scientists who don't, who go against the paradigm, are not taken seriously.
That definitely sounds familiar, and explains why so many globe Earthers don't take flat Earthers seriously.
But if that's true, then during a scientific revolution, when one paradigm is changed for another, it's not just a few theories that are changing, but the very idea of what constitutes good science. Galilei and Aristotle have very different ideas of what good science looks like. So do Chomsky and Skinner, or a modern biologist and an 18th century biologist. Before and after the revolution, people have different standards for science.
How many times do we see globe Earthers point at flat Earthers and accuse them of using bad science, and vice versa? They do it all the time when they criticize videos they've never seen before or books they've never read before. It is just because they are from an opposing paradigm.
But if that's the case, then what happens to scientific progress? For if I say that science shows progress, I am claiming that current science is better than past science. But which standards am I using to make that claim? If I am using the standards of the current paradigm, then sure, the current paradigm, the current science is better, because it obviously fits the standards of the current paradigm better than the older science did. If, on the other hand, I use the standards of the old paradigm, then the old paradigm and the old science is probably better than the current science. What Kuhn points out then is that there is no neutral standard that we can use to assess which of two paradigms is better. Kuhn introduces a technical term to capture this idea: incommensurability. Literally, it means not together measurable. In other words, two things are incommensurable when they cannot be compared using a standard that is appropriate to both. According to Kuhn, rival paradigms are incommensurable. There is no neutral, objective way to say which is better.
So according to Kuhn, a globe earther might think their paradigm is better, and vice versa with a flat earther. But from a third neutral party, there is no way of telling which paradigm is better.
What does all that mean for scientific progress? Kuhn draws the radical conclusion that you just can't say that a new paradigm is better than an old paradigm. So there is no objective scientific progress when a scientific revolution takes place.
Now this part right here is really significant because it has to do with the usefulness of the model. He is directly saying during a scientific revolution, no scientific progress happens. I don't know how many times I've seen anti-flat earthers make comments like this one. To a flat earther, this is obviously wrong. But the point is, to what standard is the flat earth being held to in the middle of a scientific revolution? According to Kuhn, it is wrong for you to expect all these great achievements in the middle of a scientific revolution.
There is scientific progress during periods of normal science. Then scientists really are building up a structure of knowledge which gets higher and higher. But when a scientific revolution comes along, the standards used by the earlier scientists are no longer adhered to, which means that the structure that they have built collapses. The new paradigm will have to start mostly from scratch. So instead of the traditional view, where scientific progress is constant and continuous, Kuhn sees progress as something that happens between revolutions. But when a revolution comes, most of the old science is discarded, and you can't really speak of progress anymore. These claims of Kuhn about incommensurability and progress have proved to be very controversial. Many people have tried to claim against Kuhn that even during revolutions there is some progress, and that paradigms are not really incommensurable.
Just remember that some paradigm shifts, like the flat earth, take a long time. And for individuals in that time, we can still make some scientific progress. For example, understanding electrostatics, as well as developing better understandings of maps and weather systems.
People have said that scientists in the old paradigm and scientists in the new paradigm often acknowledge the same observations, and that both want to explain and maybe predict those observations. If one paradigm turns out to be much more successful at this than the other paradigm, then we can say that the superior paradigm is objectively better than the less successful one. If you agree with that line of thinking, you might want to claim that Aristotle, if he had been around to see the results of Galileo's paradigm, would have come to agree with Galilei. But whether that's really true, and who is right, Kuhn, who insists that there are no neutral and objective standards, or his critics, who insist that there are some neutral and objective standards, is very much up for debate.
This video has been brought to you by Leiden University and the Flat Earth Institute of Science. Thank you all for watching. And please remember, it takes resistance to fly.